So today we are in the middle of talking about processes, but before we go over today's lecture, I have a couple announcements. So just a reminder to use EdStem for all your communications. You can send private messages there. You can send anonymous messages. So email is going to be slow to respond. So if you haven't heard back from me yet in email, just send whatever you're saying on EdStem and you'll get a much faster reply. Email inbox is very, very crowded. Use EdStem. Also, to remind you, if you want to look at the grading report that our automated tools ran to grade your project, look at the feedback repository. Anyone unfamiliar with the feedback repository? So it's part of the first exercise, the VC exercise. So you can go back to this exercise if you didn't do it and go down to the feedback repository and it'll walk you through setting it up and pulling. So if you haven't set it up yet, you won't get any feedback until after you set it up, because we assumed that it was there when we made the reports. And last thing is I added a bonus feature to the FS project. Sorry I didn't do this earlier, but now there's a bonus feature. It's totally optional, and you'll get extra points for this, up to 2 points for the project, for this project. So the project is 8 points. You could earn an extra 2 points. Every point in this class corresponds to 1 percentage point, so these are bonus points. So if you lose a point on this, you can always get points back on the bonus project, or if you lose points on attendance or other things, these bonus projects will help you get points back. All right, any questions from last class? Any questions on logistics, grading? So yeah, I think all grading should be done for Hello and VC. Any other questions? Okay, let's go over the homework from last time. And looking at it, I realized there was something we hadn't covered yet. So if you got the answer, great. If you didn't, then you'll still get full credit. Don't worry about it. But all right, so first question is, what is a process? Yeah, a running program. Well, a program that runs. I mean, hopefully all your programs can run. But yeah, it's a program that is currently running, a program that while it's running. And so it includes all of the state of the machine needed in order to continue running that process. And the reason the operating system has this notion of a process, has this abstraction, is because it can freeze and restore the state of a process. And why would we want to be able to do that? Why would we want to be able to take a snapshot of the running process on the machine? Or at least something we saw last time. What's useful about doing that? Being able to freeze a process and then restore it exactly where we left off, yeah.
You can run other processes concurrently?
Yeah, you can run other processes apparently concurrently. You can time share and switch between processes. You could also hibernate your machine or put your machine to sleep if you could save all of the current state of the process, which is basically what hibernate or deep sleep techniques do on your machines. They store the state of RAM, which holds the state of your machine, of your programs, or at least some of the state. All right, any other thoughts on processes or questions about what a process is? Okay, what about standard I/O, Unix standard I/O? What is standard I/O in the Unix world? Yeah, I heard something. Standard input and output. Okay, so in the Unix world, more specifically, what does the system give you, or what conventions are there? Yeah.
It gives you a set of input and output functions that are completely separate from the program.
So yeah, that's close. So not functions, they're files. Actually files. They're open files. So the functions are like printf, read and write. Those are the syscalls. But what all standard I/O gives you is files, 3 files. And you're right, input and output files. So it gives you input, output, and what's the third file that it gives you? Error output, yeah. And so this is just a design decision to have separate outputs for errors and regular output. It's sort of program dependent. But yeah, that's all it really is in the Unix world. It's just 3 files that the system ensures your program has whenever it starts running. So why is this useful? Why is it useful to, like, why bother opening these three files? Not all programs may output something, not all programs may input something. So why bother ensuring these three files? Yeah. You don't need, well, yeah, you don't need to code. So what don't you need to code yourself? Sure, yeah, you don't need to code open. So you don't have, yeah, that's exactly right. The programmer doesn't have to open these files at all. The system opens them for him. And what benefit does that give you? Yeah.
It works on all compatible systems, it's not just whether it works on yours.
Yeah, it's also, yeah. So it's a Unix standard, so any system following the Unix standard, your program will work on. And more to kind of put a finer point on it, it means that you as the programmer don't need to make any decisions about I/O ahead of time, necessarily. Instead, like, you don't have to decide whether the input is coming from a keyboard, whether it's coming from the terminal, whether it's coming from a file, whether it's coming from the network. You can write your program, you can write the exact same code to handle inputs from any device or any file. And same with output. You can handle any output by just using standard I/O. And if you've ever used printf and did printf hello world, as I think I showed last time, you use this notion of standard I/O. You didn't have to say write to the terminal or write to a file. You just said write to whatever the standard output is. Now that's all kind of handled behind the scenes for you. That's all kind of handled behind the scenes for you when you call printf. This is one of the many other functions that gets called when you call printf. But eventually, this chain of calls when you call printf just hard codes standard out. It just says if you call printf and you don't tell me which file to write to, I'm just going to assume you want standard out. And that assumption just makes programming that much easier. If we want to write a program that instead uses, say, networking, a network socket versus a file, we don't have to reprogram and recompile and redistribute that program. All right, questions on this notion? It's a subtle one, but it's sort of a really powerful design that the Unix designers included in their system. Questions on this? Thoughts on this? Has anyone, besides like printf, taken advantage of Unix-style standard I/O? All right, we're going to learn some ways today to really exploit this, to build up complex systems without actually writing code. We're just going to cobble together tools by using this standard I/O, notion of standard I/O. Okay, and the last one, which I did not actually get to in class, but I will get to today. But how would you save the output of running the ALS command to a file, results.txt? Anybody like look ahead and, yeah?
ls arrow sign results.txt.
Yeah, so this is ls, and then I think this is called an angle bracket, a right angle bracket. It looks like an arrow, which makes it more vivid as to its meaning on the command line. But this is like pointing to results. It's like an arrow pointing to results.txt. And this will save the output of ls to a file. Now, I didn't actually get to that last time, so don't worry if you're confused on that one. And I'm going to get to this today and show how we can take advantage of standard I/O to build and change the behavior of our programs without actually writing new code. All right, any questions on the homework? Yeah. Oh, that's a good question. I'll get to that as well. So, yeah, these notions sort of are system dependent, but we'll get to job control as well. But yeah, that is a good question, and we should get to that today. But yeah, all jobs are processes, I guess, but maybe not all processes are jobs. All right, other questions? All right, let's do attendance. Okay, let's continue where we left off with processes. So we had left off just talking about standard I/O. So you get 3 open files. Every process is kind of guaranteed by sort of the system as a whole you can think of. And we'll see how this actually happens when we write a shell interpreter ourselves. And we went over all the justification for this. So one of the first things that we can do with this is we can change the I/O to whatever file we would like. So this is called redirection. And bash, I don't actually know the history of the term shell. So sometimes bash is called the shell, that's why it's SH. And you can think of the shell or the command line as like a thin wrapper around your operating system kernel. So the operating system kernel provides the system calls, provides all the kind of low-level features of your system, and the shell is like a thin wrapper around that. So you have lots of fine-grained control over using those API calls. Yeah.
So what's the difference between like PowerShell and the actual terminal itself?
Oh, well, PowerShell is a specific Windows or Microsoft tool, but it's a shell. It's a shell. It probably just has different features. I don't actually know much about it, but there's a command prompt. These are Windows namings of tools. But from my understanding, they're all shells. They're all shells around. But PowerShell just has other features. I don't know what they are. I don't use them, but it's just a different terminal application. So in the Unix world, there are different applications like Bash, Z Shell, and they're all shells, but they're all different interfaces to the shell. Just like you have Windows versus Mac versus GNOME, different windowing interfaces. But conceptually, they all kind of serve a similar purpose, a graphical interface versus a text command line interface. But okay, so the first tool that we're going to use in Bash is called redirection. And what it does is it allows us to redirect standard I/O to a file. So normally when let's go into this file here. It's a little messy looking. So normally when I type ls, it immediately prints to my console. And the reason for that is that when you logged in through this, SSH, the secure shell, that started this shell interpreter program called Bash. And when it started, it just made the network connection your standard out. So for us, from the user point of view, this is just, it prints to our console, it prints to our screen for us. But this standard I/O has actually been set to a specific file, and that file is, you can think of the terminal itself. You can think of it's the network connection of the terminal. So that's why we get printed on the screen the output of ls. ls just lists files. So if we want to change where that output goes, we don't have to go in and recompile ls and say, all right, well, I want to write to a file now, and I'll take an option from the user to tell me the file. We don't have to do any of that. ls is just writing to standard out. So if we want to write to its output to a file, we just use this angle bracket. We can use a right angle bracket followed by the name of a file. So spacing doesn't really matter here, but I'm going to put a space there. You could omit the space. And notice what's printed on my screen when I do this. What's printed on my screen from ls? Nothing, right? So where did that output go? It went into a new file called results.txt. How can I view this file on the command line? Cat is one way to do it. So you can see the contents of this is the contents of ls. Why did it have results? Oh, I ran it already. Yeah, so I ran it before. And, it actually included the new file results.txt, which was created, I guess, before ls was run. Questions on that? So, yeah.
How to change the new line or the space into a new line?
This is an ls aspect of ls. So if ls detects that it's not a terminal output, it will add new lines. It'll add lines to it. But yeah, that's a good catch. So there's nothing in standard I/O that does this. This is the ls program, was programmed to do this. So ls does actually differentiate when it's a file versus other types, when it's a file on disk versus other types of files, but it's sort of a small point, minor thing. All right, questions on this? So if you want to save the output of a program to a file, you just use angle bracket. Right angle bracket. All right, if we want to read from a file, so let's say we have a program, I'm gonna, actually I think I have a series of examples here that I can go through. So reading from a file, you use the left angle bracket, which kind of looks like an arrow into the program. And standard error, you use 2 and the angle bracket to the right. This is actually the file descriptor number here. We'll get to that when we actually program the shell, but you can just sort of remember this is how you get standard error and save standard error. So for instance, if I tried to read, let's see, where's a file I don't have access to? Root, I shouldn't have access to. So you can see here when I try to list the files in root's super user's home folder, I get this message here on the terminal. But if I try to save the standard out of ls, you see I still get this message on the terminal. Why? Because the ls programmers have decided to write that message to standard error instead of standard out. So if I use 2 angle bracket, then you'll see it's not printed out, and instead it's inside of this error out program. So this is program dependent. It's up to the programmer to decide what they consider the kind of real output of the software versus error output. Yeah?
Is there a reason we can't run some commands in root? Is it just so we don't completely delete root, or?
Oh, this is the file permissions. So I don't have permissions as my, me as the user, I don't have permissions to read and write this file. So that's all it is. It's just the system enforcing file access permissions. That's why. Yeah, but practically the reason you'd want to do that is so that, normal users, and even you yourself, are not able to obliterate your file system or obliterate other parts of your system easily. So that's why it's good practice. I don't know if Windows used to kind of run you as an admin user by default. I don't know if they still do that. It's good practice to separate your admin user from, just give yourself a normal or limited user, just so if you get accidentally download malicious code, the impact will hopefully be a little less on you. Okay, so let's go through some examples. So cat is a program that, now that we have some understanding of Unix I/O, cat is a program that, cat is a program that reads from standard in or reads from a file and writes to standard out. So the reason I can use cat to view files is it takes in a file name and by default just prints it to standard out. That's why, results is empty, I think, and prints the standard out. It also reads from standard in by default. So if I just type cat and I don't do anything, because my terminal is standard in at this point, it's just waiting for input from the terminal until the file is over. So if I just type information here, all right, so here's my cat program still waiting for input. I was right in the middle of typing input here. And it will print out whatever input it sees to the output. That's why it's echoing what I'm typing. So I can end that input with Control D on a blank line. Control D is a shortcut for telling the program that they've reached the end of the file. So I can use this to create new files really quickly. So I can type cat and my output file. And now when I type stuff into my input, and now I end the file, where is this output going to be saved? Output.txt, right? So if I print out output.txt, it's everything that I typed into the terminal. Yeah?
So, I don't know if this could be the same thing. Is that how keyloggers would work? Or is that completely different?
Not cool. Well, in a sense, I mean, the keylogger is going to be reading the keyboard hardware, but I mean, here you actually essentially have a keylogger as the history, bash itself, but it doesn't work with standard I/O. It's not based on standard I/O. Yeah.
So could you do this with like any file, or does it only work with cat because that's like specifically made to output?
No, it works with any program. It works with any program. So ls, for instance, works. So any program that's written that uses the standard I/O, which is all of the Unix utilities, and also your own programs when you use printf, will work with this. So let me show some other programs. So yeah, it'll work with any of the Unix style programs that are using standard I/O. So if you're ever using printf or scanf, then you'll be able to do this with bash. You'll be able to save and redirect the input and output to different files. Okay, so let me show you some other Unix tools. So this is a tool called grep. I think it stands for Global Regular Expressions, maybe. And it's like a search tool. So for instance, if I have this giant header file, this is the standard IO.h. This is what you always include when you write a C program that uses standard IO. This is what the file looks like. It's a giant C header file. Has lots of stuff in it. I can use grep. The first argument to grep is a string to match in the input. So if I read this standard IO file from input and ask it to search for define, it's only going to print out lines that have the word define on it. So you can see here, it's only the subset of files that have the word define. And on the command line, grep can actually highlight those if your terminal supports colors. Okay, so that's the grep tool. So you can see if I just run this without any redirection, it's just sitting and waiting for me. Why is that? Why is it waiting here? Why hasn't the program terminated? What's that? Well, output is going to go to standard out right now, which is the terminal. Where's the input coming from? The terminal as well. So it's just waiting for my input because the terminal input is the text, from my keyboard through the network connection to this shell program, to bash. So if I start typing text here, you'll see it'll only output lines that have the word hello in them. So grep will only output those lines. So I can combine these redirections. So I could say, well, okay, find all instances of define, but use standard IO, the standard IO.h file as the input, and save the results in a file called grepresults.txt. So what output should I see when I run this? What output should I see on the terminal? Nothing, right? Because I'm redirecting all the output. And it's also not waiting for me because I've redirected standard input from the terminal, which is my connection to bash here through the network. Redirected that from this standard IO.h file. And inside of grep results, you can see here's all the matching lines in that standard IO.h file. Questions on that? Questions on that so far? And I think I gave you an example of the error before. You just save it with 2 and then angle bracket. This is just another trick to keep in mind if you ever want to improve your command line skills. You can make standard error out and standard error go to the same file like this. This is just saying redirect the standard IO or the standard error file descriptor, which is 2, to the standard out file descriptor, which is 1. But don't worry about this stuff. This is more sort of advanced stuff. Oops. Okay, so that's redirection. We can take any program that's written that uses standard I/O, and we can input and output to whatever file we'd like. And remember, files are not just on-disk storage. Files are also any I/O device in the Unix world. So that could be from memory, that could be from a network socket, that could be from a USB serial port. As long as there are drivers to turn that into a file and expose that on the file system to you, you can read and write any I/O using redirection to any program you want. Okay, questions on this so far? Questions on redirection? So this is the power of this standard I/O, this Unix philosophy standard I/O, that don't have to rewrite programs to do sophisticated I/O. Okay, so probably the coolest thing you can do with this is called pipelining. And this is where the Unix philosophy, this is the kind of the main tool that allows the Unix philosophy to work. So pipelines allow you to create complex tools from simple existing programs. So I showed this briefly last time, but a couple of points of the Unix philosophy, the design philosophy is to make each program do one thing well. So grep is a tool that just reads from input, matches lines, and writes to output. ls is just a tool that lists directory files. So I don't have to, so in the Unix philosophy, I don't need to write, I don't need to change the ls tool to match files, or I don't need to change the grep tool to list directories. Instead, if each program does things really well, and I use this notion of standard I/O, then I can combine them together without having to do any programming. I can just combine them together on the command line through pipelining. And the reason that works is because of number 2, which is basically the standard I/O philosophy. Expect the output of every program to become the input of another as yet unknown program. So ls is designed to have some output to standard out, and ls doesn't care how it's being used. It just ensures that it's being written to the output in some format that another program could use. So let me show you an example of using this pipeline. So another tool which you're kind of implementing in your FS project is called find. And find does something really simple by default. It just lists all of the directories in a directory tree, so all the files in a directory tree. So for instance, if I'm in the header file directory and I type find, it's just going to print out a list of all the files in my tree. Alone, it doesn't really seem that useful, right? It's just, well, okay, I can print out all the files in a subtree. But if I want to say search for a file, I want to search for the standard I/O file, I don't know where it is. Well, I can combine this with grep, right? So how can I do that? So how can I do that with redirection? How could I use the find tool plus the grep tool to find the full path of standard IO.h, or find where that file exists? So one thing I could do is I could use redirection to say, all right, find, and then save this to, let's do this from this directory. So I can say find user include, and then I can save the output of it to a file, right? So this will make a new file called find results. And if I look at this file, it's going to include all the output of find. And then I can use grep to read in that file with standard IO and search for anything called stdio. Questions on that? Questions on that? So I've just used redirection twice. I first used it to save the output of find, and now I'm using it as the input to grep by just saving it to a file first. And voila, I found all of the lines that match stdio in the output of find. Questions on that? Those two steps? So 2 separate tools, they do well-defined things. Find just lists all of the files in a directory. It does other things, but sort of by the default thing it does is to list all of the files in a tree, given a path. And grep, given a string to search for, will give you all the lines in an input file that match that line. So you can already see I can build, just by using 2 simpler tools, I can build up a more sophisticated file search tool. Without having to write any C code, without having to write any special purpose code, I can cobble these together. And this usage of this passing of data from one file to another is so common that the bash command line gives you a way to do this without having to save intermediate files. And these are called pipes. So instead of having to read and write files and decide what those file names are, I can use pipe, which tells the system to just immediately take whatever the output of find is and pass it as the input to grep. So whereas here, I had to run each command individually and make up a file name to save the data to and read from, with pipe, I can eliminate that intermediate file. I can just, in one command, make a file search tool with just a few characters in bash. So here's what that looks like. So same thing, I want to look inside of the user include directory, and I want to search for anything called stdio. So this is going to take the output of this program, whatever this output is, and it's going to redirect it not to a file, but it's going to redirect it to this program. Because grep was written to use standard IO, use standard in, and find was written to use standard out, all this pipe needs to do is to just take whatever this output is and pass it to the input of grep without any rewriting of find or grep, no special features of find or grep. Because they're using standard IO, this is possible. Those two programs don't need to know about each other in any way. Because they're reading and writing from standard IO, Bash provides this feature called a pipe, which will, like plumbing, add that plumbing between these two programs. Okay, let's see it run. You can see it does the exact same thing that I did before, where I had to save a file on disk. This also, by the way, avoids actually using storage on disk. You don't even have to, fill up your drive with output to do this. Yeah.
So when you use a pipe, it's not like necessarily saved anywhere, as opposed to like if you use
Right.
a middle text file.
No, there's no guarantee it's going to be saved anywhere. So I think what happens in most implementations is there's going to be an in-memory buffer that the kernel is going to, or the bash is going to create for you, or actually what the kernel is going to create for you. So it'll create an in-memory buffer to pass that data along. And it also means that because as long as this program is consuming input, you don't actually have to store all of the input anywhere. You can just have a small buffer. You can have like a 1K buffer. Once that's filled up, pass it along to the input, and find can just wait. It'll write to the output. Because it has to call this write syscall. The system may not write all of the data, or it may pause. While waiting for that buffer to be emptied by the input. Yeah.
You do like multiple pipes.
Absolutely, you can do multiple pipes. So any questions on that? Any other questions on this before I move to multiple pipes? Yeah.
Didn't you also use a makefile to do this?
Well, you could put this instruction in a makefile, but the makefile itself is just a tool for running those rules, those recipes for building programs. But in the process of doing it, you could use pipes as part of the commands, but make itself does not do this. Yeah.
So the first argument is automatically the input for the second argument?
Yes, that's right. So so if you think of this find user include, this is the left-hand side of the thing. It's like an operator, like a plus sign or a multiplication sign. The left-hand side of this is always its output is what's going to be taken by the pipe, and the right-hand side, the input is going to be taken from the pipe. Other questions on this fancy tool? Okay, so we already kind of covered this already, but what are pipes? The operating system will actually this is actually a feature of the operating system. It's something that I think Unix introduced this design, correct me if I'm wrong. But there's actually a syscall for creating these special pipe files. And what the operating system does is it creates two files, because remember, the files are not data on disk. A file is this operating system abstraction that allows you to read and write stuff to it. So the file itself doesn't have to be backed by storage. It's just some file descriptor that you can call read and write on. So what the operating system does, it creates two of these files, one for the input, one for the output, and it, under the hood, constructs this connection between them. So whenever you write to one end of the pipe, you can read from the other end of the pipe. So it links these two files under the hood. And this is what allows processes to pass data between them. If you ever heard the term inter-process communication, the process abstraction, the program thinks it's the only program running on the computer. So inter-process communication is a fancy term for just how do you get processes to talk to each other, send data to each other. This pipe tool is one way to do that, one way to solve that problem of isolated processes. Okay, so let's look at multiple pipes. Somebody asked about sequence of pipes. So you can string together I think a very large number of these pipes together. So here's my first pipe where I pass the output of find to the input of grep. And I can keep this pipe going. So I can take now the output of grep, and instead of having it go to the terminal, I can pass it to yet another program. So I'm going to pass it to WC, which is word count. This is going to tell me the number of lines in the input. And so now I've created a tool that will not only search for a file, it'll also help count how many the results are. All without any new programming, without any changing of code, just by using standard I/O and redirection and pipes. I can cobble together larger, more complicated tools that you might have to download some fancy program to do that. I can cobble them together using existing tools from the Unix kind of standard set of core utilities. Questions on this so far? Now, pipe redirection between programs can also be combined with file redirection. So I could, at the end of this chain of pipes, you can think of this as one single command that produces standard out, and I can redirect that standard out to a file. So I've taken whatever the output of find is, redirect it to the input of grep. Whatever that output is, redirect it to the input of the word count program, and then redirected the output of that program to a file. And now I can actually save the results of my new tool that I created with pipes. Questions on this? That's also true for input. So if I wanted to do grep with find results, so this is how I redirect the input of grep to be from this file, I can combine this with other tools. Yeah.
If you want to save any of the intermediate data, can you do that, or can you only save the last file output?
There is a program called T. T will write to both standard output and to a file. So there's a utility that you can pipe to do that. But yeah, that's a common thing you might want to do. But if you wanted intermediate files, pipes might not be the right tool anyway, if you're trying to do that. All right, questions on this? Has anyone used these before? Not many. Interesting. Okay. So yeah, this is kind of a classic, powerful tool on the command line. One more utility that you can pipe to is called xargs. What xargs does is it takes whatever lines from the standard input and it turns them into command line arguments. So let me show you an example of doing this. So I'm not going to go too deep into this because this is like a lot of command line hackery. But let's take this command here. So what does this command do, or this pipe do? Ignoring the special characters here, I'll just take those out, make it .h. What do you think this pipeline is going to do? Find all the lines with .h in it. Now I have to do a little extra characters here to say find an actual dot. Dot is a special character in regular expressions. Anyone deal with regular expressions before? Anyone learn about them? Oh, not that well. Okay. And this money sign just means look at the end of the file. Don't worry about that too much, but this is going to find all of the files that end with .h. So a way to find all the files that end with .h. What xargs does, and there's a tool called head, which shows the beginning of a file. So if I do head for standard IO.h, it's just going to show by default the first 20 lines of the program. So kind of a preview of the file. So I can create a pipeline that takes all of the files that end with .h, and with xargs, I can effectively run head on each of them. So xargs is a way to say, run this program on each of the lines of input for my program, so it turns this into a series of calls to head. So when I run this, what do you think's gonna happen? Or can you guess what's gonna happen? What am I gonna see? Yeah. Yeah, exactly. It's gonna print all of these files that were matched by find and grep, and it's gonna run head on each of them and print out the beginning of each of these header files. So it's a lot of stuff. So it prints out, it actually gives a little output to tell you which file it's being printed out. But anyway, so it's just, kind of more command line tricks, just to keep, in your tool belt if you ever actually get to do some command line stuff. And I had an example of some I actually use this commonly, like in my research, to do quick stuff on the command line. So I won't show this too much, but this is a really long sequence that I've actually you will use by combining, file search, and I can use this to actually look inside of files. So I can say, match all files that have this name, and then look inside of each of them and find a line. So I'll use this for searching through stuff by just cobbling together these several tools. So there's other tools like sort, unique, finding unique lines. But anyway, I'm not going to go too much into those. I'm not going to test you on that. But I just want to show you kind of the power of this. This is like a 1, 2, 3, 4, 5 or 6, pipe command here that I can use to do some stuff that you might download a tool and use a graphical editor to do. I can do this stuff on the command line by just cobbling together tools. And one other little trick, if you want to pipe both standard air and standard out together, you can use this. I think this is a bash specific thing. All right, questions on redirection or pipes? Yeah.
I guess just real quick, what happens if one of the chains of the pipe fails?
Yeah, if it fails, then I think the whole pipe will fail. So we can do something like try to read root and look for files and see what happens. I think so what'll happen is this program will terminate, and therefore its output file has closed, which will end the input file of grep, and then grep will terminate. So it'll kind of just naturally shut down by itself. But if something fails or hangs, then the whole pipe may be waiting, maybe hanging and waiting. If find doesn't actually fail by exiting, it may continue the other and doesn't actually issue an end of file signal, then the other inputs may be waiting for that indefinitely. Kind of like when we just wrote grep hello on the command line, and it's just waiting. But yeah, if one of the programs terminates, then its file closes, its standard out or in file closes, and then the rest of the pipeline can continue without any of that information. Other questions on redirection and pipes? So this is kind of like one of the core low-level things you can do with the kind of Unix-style command line, because these features, this process management and pipeline features and file management features, these are all built into the design of Unix, and Bash just exposes a really lightweight wrapper around them. And so you're really just, when you put a program's name in, like grep, you're telling Bash to create a new process for it. And when you're using an angle bracket, you're telling Bash to change the standard I/O, and when you're using a pipe, you're telling Bash to create multiple processes and link their inputs and outputs between them. So with just these few simple kernel syscalls, you can do some pretty powerful system building, some pretty powerful stuff on the command line. All right, so let's look at, so somebody asked about processes versus jobs. Now, jobs is a term that other systems use, sometimes also for processes, especially batch systems, older kind of mainframe style batch systems. In the Unix world, I'm going to talk about the kind of bash Unix world version of jobs. But jobs are effectively processes that you manage from your command line shell. So for instance, on this system, if we go into like use this, and look at a system like Eustace, which has lots and lots of concurrent users, there's lots and lots of processes running. So in the Bash world or the Unix world, jobs are the processes that you control from your Bash session. Okay, this is going to take a long time. I'll show you that. Oh yeah, there we go. Oops. So tons and tons of processes. These are all the processes running. And notice, the PS command also writes the standard out. So if we want to search for stuff, like search for all the stuff that I'm running, I can use grep with PS as well. This is like the power of using pipelining. So there's all the processes I'm running. But there's tons and tons of processes running here. I can also count them roughly. So there's hundreds of processes running on this machine. But jobs in the Bash world, jobs are the processes that I'm managing, ones that have been spawned from this current process that I'm in, current Bash process that I'm in. Okay, so first kind of a useful one is Control-C. Who's used Control-C? I think everyone probably knows this, right? Control-C kills a program. So if I have this long running program, if I try to list every file in the entire Eustace file tree, it's going to take a very long time. Control-C sends a signal to kill that process that I've created. If I want to suspend a process from the command line, I can use Control-Z to suspend it. Control-Z, and you can see there's a little message here, stopped. So this is where Bash job control comes in. So if I type jobs, it'll tell me what programs are currently running from this session, and it actually gives them a job number. It tells me their state, whether they're stopped, whether they're running. So questions on that? It's just a way to see which processes I've paused in my current, or paused or have running in the background in my current session. Control-Z. Command is a Mac thing, I think.
How would you, I don't even know how to word the question, how would you,
Unpause it, good question. So there's a command called FG for foreground. So if I have some job in the background, I type FG for foreground, it's going to continue running. So foreground versus background. This is not a notion that's baked into the Unix design. This is really just the shell. So foreground means the terminal's standard I/O is connected to that process. Background means it's not. So for instance, if I run find on the whole root, let's say I run find and grep. I want to grep for standard I/O on the whole file system, and I want to sort it. I want to sort my results and save this to some file. Okay, let me also redirect. Let me redirect the error as well, so I don't get these messages. But you can see my terminal just seems to be hanging. That's because this program is running in the foreground. That is, my terminal input, my terminal I/O, is waiting for this program to end. But I can pause it with Control-Z, and just like FG puts into the foreground, I can say BG. And it's still running. The program is still running. You can see the process. Well, okay, it finished, but it finished quickly. But you can see that if I pause it and put it in the background, you can see that all these programs that I invoked, find, grep, and sort, these processes are still running, even though I can actually run I can use my command line. All these processes are running. I can actually interact with my shell. This is what background means. It means you've invoked the process and it's running on your machine, but you can still use your Bash shell to run other commands. Right, so you can't run additional shells. It also means you can't run Control-Z on it, so if I put this in the background, Control-C is not going to do anything. It's not going to stop it. It's only going to stop, that's only going to kill programs that are in the foreground, Control-C. So if you have something running in the background, you're not going to be able to kill it with Control-C. Yep, I already mentioned this. You can put stuff in the background with BG for background, and it'll continue running until it's finished. So you get a little message that it's finished. And there's my results. That's everything that matches stdio, all nicely sorted for me. Okay, so you can put stuff immediately in the background using this special character in Bash, the ampersand character. So if I put ampersand at the end, it'll immediately go in the background. So you can see it's still just finished. So let me show that again. It'll immediately go in the background. If I type PS and jobs, you'll see these programs are running, but I can interact with my shell. The job control tells me that the program's running, and I can still interact with my shell. So eventually, that program's going to be done. You're not going to get any like event that tells you when it's done. You can just run jobs, or the next command you run, it'll tell you whether the job finished. And I already went over this, viewing jobs, so you can use the jobs command to tell you what jobs are currently running. And FG and BG actually, FG actually takes a number, the number of the job, so you can decide which one you'd like to foreground. Just a little point on Control-C. Control-C kind of asks a process to terminate, but you can use the kill command to send a signal that cannot be, so processes can, or programs can actually be written to reject or just ignore that signal, but you can tell the kernel to actually like truly kill a process if you want. All right, so one reason I'm showing you this, one is to show you that you can kind of harness the power of this multi-process system and the Unix style of system building and the Unix style of I/O. And you can harness that with just typing commands on the command line. You can do some very powerful stuff by cobbling together programs like Lego blocks to build bigger programs. But we can also use this to have a very fast development workflow on the command line. So up to now, when you did your Hello World program, you had to like go into Emacs, you had to quit, you had to compile it, then open up the file again, use the arrow key to go down to the program. But because we have a multi-process system, it's not windowed, so it doesn't show you as easily. But we still have a sophisticated multi-process system that can run multiple programs at the same time. So we can use these features to create a faster development workflow for us on the command line. So let me show you an example. I'll use the Hello program. So let's say I've written out my Hello program, and I made a mistake, like I messed up some punctuation, some spacing. Now normally you would just like quit the program and recompile it. But this is just a process like any other that's running in Bash. So I can use Control-Z to pause that program. And so now I've got an instance of Emacs still running in the background. Or at least, well, it's not running, it's suspended. But that process still exists on my system. And using FG, and I can resume running that instance and reconnect it to Bash anytime I like. So if I type FG, voila, I'm back in my Emacs editor, right at the same place I left off. So you don't have to, on the command line, kill your program, exit Emacs, go back into it, hit the arrow key 100 times to get back to where you were programming. You can just suspend the program and then run your compiler. You can run your program, and we can see that it's broken. So if I use FG, sorry I did that real quickly, use FG foreground to go back into your editor, and now I can make my changes here. And without quitting, again, I can recompile and rerun and see my updated program. Questions on that so far, that workflow? So I've given you an example of it here. So you type Emacs. You could also use this if you wanted to. Emacs does support opening multiple files, but if you wanted to do it this way, you could open multiple files or open multiple Emacs processes and have multiple Emacs processes suspended. So now when I type jobs, you'll see that there are two instances of the Emacs program running, two processes running. And with FG, you can select via the process number or the job number which one you'd like to foreground. So foreground 1 is going to foreground Emacs hello.c. Foreground 2 is going to bring Emacs makefile to the foreground. And so remember, jobs will show you that. Questions on this? Yeah.
Is there any command in X that runs in the background instead of like pausing?
Yes, so BG will make it run in the background. It's a little scary to do this with Emacs because Emacs is, well, okay, so Emacs will suspend itself anyway because I think it requires the input from the user. But BG will take a running program. So if I take a long running program like this find program and I put it in the background, I can use BG to put it in the background. So you can see that this long find program is still running while I'm doing other stuff on the command line. Actually, a much easier way to do this, there's a program called wait, which I can tell it to wait for 20 seconds. Oh, wait. Oh, sleep. Sorry, sleep. I can tell it to sleep for 20 seconds, put it in the background. You can see that sleep is still running. The job is still running. I can do more of these. Sleep for 30 seconds, 39 seconds. Sleep for 1 minute. And so you can see I have these multiple jobs running, and each of these is a process running. But yeah, BG will put a suspended program into let it continue running in the background. One thing you want to be careful of if it's a little hard to show here, but if you have, so like I can put this into the background immediately using ampersand. If I didn't redirect this output, then it would still, the standard I/O is still going to show up on my terminal. So even though it's in the background, you can see I'm getting the output on my terminal. So it's going to be very hard to use your terminal if you haven't redirected all the files. Yeah.
If you have multiple jobs and you just use FG, does one take priority or does it do stuff?
I think it does the first one. Yeah. So this is another Unix philosophy, have good defaults. So that's why you can just run ls by itself. You can run find by itself. You can run FG. Sorry, this is not a separate tool. It's part of. I think it just does the first one, but I'm actually not sure. I'm not sure. Oh yeah, wait. Naming a job is synonym for bringing job one. Yeah, I think it's the first one, but I'm actually not sure. But by default, it brings up one. Maybe it's the last one that you suspended. I'm actually not sure. But yes, it does have a default. Other questions on job management and this workflow? So hopefully this will make a little, this with autocomplete, tab completion, which is like autocomplete, with using the history, the bash history, you can very quickly have a very fast development workflow. So FG to go back in, do my changes, Control-Z to suspend, go back in the history to rerun the compiler and the program itself, and you can very quickly do development. All right, I think that's it. So there's some useful tools for, those are the useful tools in here. You can check out this tool called Biobu, Tmux. I won't go through those, but yeah, that's all I wanted to show. Redirection, standard I/O, pipelines, and job management. All right, everyone, have a good one.